Well, as it's always the case with me, I do mistakes out of no experience. You see the hole there. I aligned this hole from the other side, from the back, by placing this as a mirror image on the other side. So I put it on the wrong, I put the hole on the wrong place, and this is not like that where it should be. It comes about here. So now I have to drill a second hole a little bit that way, so that I line the back hole with those two. I would do many things differently if I knew before I started this project. First of all, I would use this kind of diodes all over and not use these big diodes here. Second of all, I would use a different different lane for minus, since minus is common on everywhere. So I would use another lane for minus, so that they don't have to cut the lane each time. So one lane for all of them, and then I would cut only the plus lane and not the minus lane. That was a mistake I did. Anyway, now I will try to screw this on the chassis, and then try to solder back all these colors. Thankfully I have taken notes of everything, and I hope I don't miss something, but let's see. So this is my final approach to the power supply. I 3D printed those brackets here. Let me try. I will turn on the light. Wait. So now let me show you. Here I have an additional screw there, and the old screws there, one there and one there. You can see them there. Let me try and show you the other screw at the back. Cannot be seen, but it's back here. Here you can see it. There it is. And two more screws here. You can see this is for the ground, and this is the other side. You can see I used a little piece of plastic irrigation tape. This is plastic stuff after I drilled holes on this one, there, on there. So these are small pieces of small plastic irrigation pipe that I used here as distances. I would just cut the pipe and put them there, so that I keep a distance from this to the chassis. And then I made these brackets here to hold this, which is nearly at the same place as it was before. All alternating current cables back there are soldered correctly. It's 6 cables there, 6 cables for alternating current. And now I'm gonna have to solder back all these cables that I took detailed notes on how they should be soldered on the capacitors here, to have the thing properly rebuilt. One resistor here is missing, and I will put this also. Okay, not this one. There is another one. There should be there. Now there are 1, 2, 3 resistors. Let me show you 3, and there should be another one in between there. Don't forget it. I don't remember. I think it's R. Which one is it? I think it's this one that it's missing. 115. That's going in the middle of there. And then I will check the voltages after I solder everything back. I will check the voltages and see if I have any mismatch, so that I gonna have to correct something. Okay, let's see. I will solder them all back and see what's going on. Okay, let's see. First, 1K resistor that was missing in there. Okay, and now I should start doing all the cables one by one. So I have my notes here of all the cables. So what do we have? Yes. So we have a gray cable which would go to number 4. So this is a gray cable that should go to number 4 to the first capacitor. Where is the thing that I'm holding stuff with? I always miss stuff. Oh, there it is. So this from the first capacitor to number 4. The first capacitor is there. This is finished. Next, we have a white wire, which is that here, to the second capacitor. Okay, let's solder this white wire to the second capacitor. Finished. And a double gray wire to the third capacitor. This is the double gray wire that should go to the third capacitor. Finished. So first capacitor is complete. Second capacitor, we have the first is a red wire that goes back. This is what goes back, and there is a red wire to the first capacitor, which is that one, and that should go there. This is finished. Then the second has a green wire that goes to number 9. The second is that. The green wire that goes to number 9 should go to the second capacitor, which is here. So let's do this. did burn here some cables. Yeah, don't worry. So green wire to the second capacitor finished. Fine. And the third capacitor, there is an orange wire. There is an orange wire, and I guess it's this one here, that goes to the third capacitor. Where is the third capacitor? It's hidden back there. Not easy to do this in between all these wires. And it's the orange wire that goes this way, so it's that here. Let me go inside just like that, and okay, this is soldered, and then but there is another orange wire which is here, which is goes also to the sixth capacitor, is the third from the second bands, and that should be here. I've been burning other wires on the way, but generally I hope I'm doing everything correctly. So, and then we have the third capacitor, which is a bunch of three capacitors. The first is yellow, so this is the yellow, and the yellow goes, let's see, 1, 2, third. The first is yellow, there it is, the yellow, and I will solder it. Maybe I should start soldering from this side there, because now I have all the cables in between. Another mistake that I did, that I should have known, but anyway. So, yellow, next we have a green, the next capacitor is a green wire that should be soldered there. Okay, and the last one is a blue that should be soldered to the last capacitor. This one, I think I can access it from the side here. Let's see. Right there. Finished. And then we have this resistor here that goes to the third capacitor from the second bunch. So this capacitor should reach I will add some more solder. Okay, on this capacitor. Not easy at all. It's 1, 2, 3, 1, 2. It goes to the third. 1, 2, 3. It's go. This is really populated a lot. Okay. So this capacitor goes to a place where I already have two orange wires, so it's really populated. So I can see now. Well, another thing I should do is I should make pads here in front of this here, so that all these cables in there should just go in here, here in the front. But anyway, now I think I soldered them all. I will try and see if I have any loose cables, and if so there is a white cable here which is loose. Let's see if I have any more loose cables, which means that I forgot something. So apart from this, which I think it's ground, I think I don't have anything else to solder. Let me just check where this white is. So that last white cable here was a ground cable that I installed back there on the ground of this last capacitor. Generally, all cables are soldered on. And now I will have to do the most difficult part for me, which is to lower the chassis on its original position, put back the valves that I took out, and power on the machine and see if everything is correct. So this is all finished and ready in its position. I'm so worried that I've been smelling burned stuff even before I turn it on. And let's see now what will happen. Okay, I got no smelling stuff. I just turn it on and off completely. So nothing is burned. Now I will check some voltages. Just let me show something. Remember that this is loose, the screws are not in there, so this part here is loose, as you can see. Just I wanted to show this, that as a precaution, when I turn it on, I put this piece of paper here to avoid any sorts of the whole mechanism with these two rods, okay? That's just saying. Okay, let's check the voltages. So, first capacitor, let me put this. So, first capacitor should be the opposite. First capacitor should be 27, and it is exactly. Let me double check. Look at that. Anyway, second capacitor should be 24. Let's see. Second capacitor is there. 23, 24. How correct? Third capacitor should be 12. This is correct. First capacitor should be of the second bunch, so fourth capacitor, 165. Let's see. It's more. This is a little bit more. This is a little bit more. Next, there should be the last capacitor, the first bunch of the last capacitor, which is there. 141, 120 it should be. Second, 207, it should be 190. The last one should be 182, and it is 198. So it looks that I didn't solder anything bad, but the capacitors of the voltages of the high voltage should be a little bit less. What we can do, you see that 1K capacitor, we should either put some voltage on this capacitor, some resistance on this capacitor more, like 1.2, I don't know, or a little bit more on that. And this 265, how big was the 165? Let me see. 165 was 180. So this 165 is a little bit more than it should. I should check this more, a little bit more, let's see. Well, unfortunately it didn't go well. I did everything, and I put this in there, doing all the connections, and although it would play perfect, not perfect, it would play, both channels would give output, everything was working, there was a very audible hum. So that means that my capacitors sort of were not enough. I don't really know why. I I even scoped the outputs to the power outputs to see how much ripple I had. There was some ripple, like about 6-7 volts on the high voltage lane, but I didn't know if that is enough or not. Maybe I will now try and do this again with the scope. There, my scope. I even put a 220 ohm resistor in series with the high voltage lane, just to reduce the voltage a little bit, because let me show you. On this voltage lane I would have 273, and I would have all these voltages that were above, which is not a mistake, because the silicon rectifier here, the diodes that I used as rectifiers, would obviously have less voltage drop than the selenium rectifier that I had. After I put the 220 ohm resistor, all these voltages would be nearly correct, but still the hum was audible. So I don't know why. I will scope the power outputs and show you the results, but now I was too frustrated to take a video of all the procedure. I wanted to get over with, because I was angry that it didn't work correctly. Anyway, let's see how much ripple we have now. So let's power this thing on. Okay. Here I attach the scope to the high voltage lane, and the high voltage is, let me see, so is this, okay, it is on 10 times, menu, yes, that is correct. Okay, here you can see the voltage, which is 136 to 152. There is a ripple now also. And if I change the voltage to AC, so that we see how much ripple we have, so this is the ripple. Let me measure. So we have about 8 volts ripple. That means that capacitors cannot sustain the voltage too much, and until the next cycle the voltage will drop 8 volts before the next power line cycle comes and starts raising it again. Let's see the lower line voltages. The lower line voltage has a ripple of about 3 to 4 volts. Let me show you the voltage exactly. So if I move this to DC, here we can see it. Let's see, measure. It's about 23 to 27. There is enough ripple. Anyway, and let's check the filament voltage, which is 22 to 24, which is normal, and let's check the ripple. You can see the ripple, which is about 1 volt, 2 volts peak to peak. You can see it here. You see? The frequency is 100 Hz, which is normal. It's 50 multiplied by 2. 50 Hz, it's the voltage we have here in Athens. So, although with my power supply here, I did have ripple, the same as I have here, but the hum would be very audible. And now with the original capacitors here, there is no audible hum. I don't really know why, but I will leave it like that now, because I'm working about 2 days on this thing, to build this, to design this, to put it here and secure it there and all this stuff. So I will consider this working as it is without this modified power supply, and until something goes wrong, I will not touch it again. Bye bye.